and welcome to another FFplus episode. Today we are hosting Alessandro Arcidiacono, head of the CFD Turbomachinery Unit from Enginsoft, which is an Italian consulting company specialized in the field of computer-aided engineering. Alessandro, welcome.
Thank you.
So, to start, could you briefly introduce Enginsoft?
Enginsoft is an Italian company that works in the field of simulation-based engineering sciences, also known as computer-aided engineering. In simple terms, we help companies use advanced simulation technologies to design, test, and improve their products digitally before they are built, of course. We have been doing this for many years, decades, and today we operate not only in Italy, but also in countries like France, Germany, the UK, Turkey, and also the US. Our work combines technical expertise with collaboration. We support customers from many different industries, such as automotive, energy, aerospace, manufacturing, consumer goods, and healthcare and more. Our services range from technical consulting and specialized software support to customized simulation solutions and training. What really distinguishes Enginsoft is our multidisciplinary approach and the ability to integrate different technologies to help companies innovate and make their development and manufacturing process more efficient. Today, our vision is to move beyond being just a technology transfer company. We aim to be a full service partner for engineering simulation and data analytics, helping companies through the digital transformation from design all the way to industrial automation.
So, thank you for this introduction. From your perspective, what are the most transformative trends that are currently shaping the future of Industry 4.0 and 5.0, particularly in relation to technologies such as simulations, as you already mentioned, CFD, data analytics, and smart systems?
Well, when we talk about Industry 4.0, and the transition to Industry 5.0, the biggest change is really the shift from pure automation and efficiency toward a more human-centered, resilient, and sustainable approach. And in this evolution, technologies like AI, data analytics, and simulation play a major role. Industry 4.0 was mainly about connecting machines, automating processes, and improving efficiency. Industry 5.0 keeps those elements but adds a stronger focus on people and sustainability. AI is evolving predictive analytics from a simple tool to a collaborative one. Systems that adapt, understand the context, and support human decision making rather than simply automating tasks. In the world of engineering simulation, we are seeing a big transformation. We are no longer using simulation only as a design tool, but as a real-time component of intelligent industrial systems. Physics-based models are now being combined with data-driven methods, reduced order models, and AI surrogates. This opens the door to faster, more flexible, and more realistic simulations that can run continuously throughout the entire process. Of course, real-time simulation comes with challenges. As always, accuracy, model reliability, and ensuring that results are used correctly. But the potential is huge. And finally, as digital transformation accelerates, computing power and data centers are becoming critical. They support everything from AI workloads to real-time simulation. This also means energy demand is increasing. So, as we build more powerful digital tools, we also need to be responsible about how we use and manage that energy.
Mhm. So let's turn now back to the simulation you already mentioned. So how actually is simulations, you mentioned also real-time simulations and CFD simulations specifically, transforming the modern engineering processes. So could you share with some specific tools and solutions that your team is developing? Maybe illustrate their impact in the world and the application.
Yeah, well, simulations are really changing the way engineering is done. In the past, they were mostly used during the design phase to check the performance or optimize geometry. Today, simulation is becoming an integrated, intelligent, real time tool that supports decisions uh, throughout the entire life cycle of the product, from design to maintenance and even end of life. To really unlock this potential, one key aspect is establishing proper simulation governance. Simulation is no longer just a technical tool, it's becoming a strategic component that influences real world actions in the real time. That also means error or biases can spread quickly if the process is not well managed. So, governance becomes essential. Defining adoption strategies, setting standards, managing risks, and ensuring trust, sustainability, and knowledge sharing across the organization. A concrete example is a project we are working on under the European Recovery Plan, the PNRR, the Italian one. We are supporting a medium sized Italian company that is fully digitalizing its product design process. We are helping them automate the entire workflow from parameterized CAD to structural and CFD simulations. The real innovation here is that uh, instead of relying only on traditional best practices, the process is totally automated and optimized using advanced response surface models, which make everything faster and more efficient. And we are also helping them leverage high performance computing by increasing the use of GPUs, for example, which further boosts their simulation capabilities nearly 10 times faster.
So let's now turn to your experience with Fortissimo initiatives, particularly your participation in the FF4 your HPC experiment. Could you briefly introduce the project that you collaborated with CDR Pompe and Cineca to optimize magnetic drive pumps? And what innovative solution was developed in this case, and what impact did it have on the product of the process?
Sure. In the Fortissimo 4 UHPC experiment, we worked with the SME CDR Pompe and Cineca on a project called HPC for POP, which means high performance computing for performing optimized pumps. The goal was to redesign and optimize four sizes of magnetic drive pumps. CDR Pompe wanted to improve pump performance, lower manufacturing costs, and meet regulations abroad while staying competitive. To do that, we relied heavily on high fidelity CFD simulations. These models are very computational demanding because the magnetic drive pumps have complex geometries and need to be simulated under real operating conditions. Thanks to access to HPC resources within the project, we were able to run large scale CFD simulations and then perform geometry based optimization for each pump size. In total, we ran around 130,000 core hours and evaluated more than 80 design points per pump. From this, we generated performance maps for head, efficiency, power, and axial thrust. Basically, everything needed to significantly improve the pump life and performance. The impact was substantial. The HPC-driven design process cut time to market by about 50%. And CDR even expanded their internal simulation and design team because they saw how valuable these tools were for their business. In the end, the new pump designs showed better reliability, reduced noise and vibration, higher versatility, and a longer lifespan, while also reducing both planned and unplanned downtime.
So actually, great benefits and outputs at the end. So this was actually the goal of the project, right?
Yeah, exactly.
Yeah. And now we are going from FF4 Euro HPC to the FFplus series. So you also successfully applied for the open call for innovation studies. And how does this case actually differ from the one that you developed under the FF4 Euro HPC?
Yes, this project under the Fortissimo Plus open call is quite different from the one we did in Fortissimo 4. In this case, we are working with Exergy and Lux Provider to improve two different sealing systems for Exergy's multi-stage radial turbine, uh, which is a kind of type of turbine used in organic ranking cycle plants. The idea is to increase the turbine's efficiency so Exergy can be more competitive in the waste heat recovery market, especially because this type of turbine often operates under very tough conditions. Compared to the previous project, where we focused on optimizing pump geometries, here we are working on and optimizing sealing technologies. The standard labyrinth seal will be redesigned for different operating conditions, while a completely new brushed seal will be validated both experimentally, use a test rig, and numerically, using advanced open source CFD tools such as OpenForm. Again, high performance computing is essential, also in this case, because these simulations are very demanding. We are modeling 7 turbine stages, which is quite a lot, and need parallel computation to run efficiently. In this project, Enginsoft is responsible for all the fluid dynamics and CFD work, and Lux Provide is supplying the HPC hardware and the technical support needed to run the large-scale simulations. So, overall, the main difference is in the application and the tools. Instead of optimizing pump designs, we are improving sealing systems for a power generation turbine and combining open source numerical and experimental validation in this case.
So two different cases and both very specific, actually. And this brings me to the question: how do you see the opportunity to enter the Fortissimo open call for your company? Especially if we are talking about in terms of innovation, development, and collaboration with other partners. So what true benefits did the project give to you at this point?
Well, the Fortissimo open calls always have been extremely valuable for us. As a technology partner, we have been able to prepare, run, and post-process complex simulation models on HPC systems. And this has helped us and our customers apply advanced technology to improve their machines and products. These projects also allowed us to strengthen our expertise in HPC services, both in consulting and technical support for different industry and end users. On top of that, the calls have helped us widen our network, increasing collaboration with other partners, and grow our visibility. Internally, they have also pushed us to invest in new professional profiles, especially in areas like programming and open source development, which are becoming more and more important. So overall, these open calls have been a catalyst for innovation growth and skills development inside the company.
Okay. So at the end, let's wrap up this interview with some final thoughts. So what advice would you give to other SMEs that haven't yet explored the use of HPC or AI in their business?
Well, my main advice would be don't underestimate how much HPC can accelerate your digital transformation. Both AI and traditional simulation tools are growing rapidly, and computational power is becoming much more accessible. For SMEs, this can translate into real competitive advantage. What we have seen with the Fortissimo project is that the HPC access is now much easier than it used to be. It removes a lot of barriers, uh, both technical and financial, and it helps companies address knowledge gaps in simulation or HPC, just just like it did for CR, Pompe, or Exergy in our cases. So I would recommend SMEs to take the opportunity to experiment with HPC through these open calls and see how it can improve their products and processes. It's a very efficient way to prepare for the future and stay competitive, I would say.
Alessandro, thank you very much for this insightful interview. It was a pleasure to having you with us. And at this point, we wish you all the best in your future endeavors. Goodbye.
Thank you. Thank you, Tina, for the opportunity, and thank you also for the public.